Again, welcome to the course. The topic of today's lecture is risk management, and risk management lecture is part of information security audit. In this lecture, we will cover risk assessment, risk mitigation, and controls. Okay. Start with what is cybersecurity risk? So, cybersecurity risk is the probability of exposure or loss resulting from a cyber attack or a data breach on your organization. A better definition is the potential loss or harm related to technical infrastructure, use of technology, or reputation of an organization. Actually, risk is the net negative impact of the exercise of vulnerability, considering both the probability and the impact of occurrence. Nowadays, organizations are becoming more vulnerable to cyber threats due to the increasing reliance on computers, networks, programs, social media, and data globally. Data breaches, a common cyber attack, have massive negative business impact and often arise from insufficiently protected data. Global connectivity and increasing use of cloud services with poor default security parameters means the risk of cyber attacks from outside your organization is increasing. What could historically be addressed by IT risk management and access control now needs to complemented by sophisticated cybersecurity professionals, softwares and cybersecurity risk management. So it is no longer enough to rely on traditional information technology professionals and security controls for information security. So there is a clear need for threat intelligence tools and security programs to reduce your organization's cyber risk and highlight potential attack surfaces. Therefore, decision makers need to make risk assessment when prioritizing third party vendors and have a risk mitigation strategy and cyber incident response plan in place for when a breach does occur. Now comes to risk management. Risk management is the process of identifying risk, assessing risk, and taking steps to reduce risk to an acceptable level. The principal goal of an organization's risk management process should be to protect the organization and its ability to perform their mission, not just its IT assets. So, importance of risk management is it encompasses three processes: risk assessment, risk mitigation, and evaluation and again assessment. Now comes to first step of risk management is risk assessment. Risk assessment is the first process in the risk management methodology. Organizations use risk assessment to determine the extent of the potential threat and the risk associated with an IT system. The risk assessment methodology encompasses 9 primary steps, which are system characterization, threat identification, vulnerability identification, control analysis, likelihood determination, impact analysis, risk determination, control recommendations, result documentations. All these steps we will discuss is next slide in detail. Okay. Risk assessment methodology. This flowchart is showing steps of risk assessment methodology, and here I am going to explain each step in detail. Okay. Step first is system characterization. Characterizing an IT system establishes the scope of the risk assessment effort, delineates the operational authorization or accreditation boundaries, and provides information For example, hardware, software, system connectivity, and responsible division or support personnel essential to defining the risk. Here, the input is system related information. Identifying risk for an IT system requires a keen understanding of the system's processing environment. The person or persons who conduct the risk assessment must therefore first collect system related information, which is usually classified as hardware, software, system interfaces, for example, internal and external connectivity, data and information, persons who support and use the IT system, system mission, for example, the processes performed by the IT system, and also system and data criticality and sensitivity. Additional information related to the operational environment of the IT system and its data includes, but is not limited to, the user of the system security policies governing the IT system security architecture, current network topology, technical controls used for the IT system, flow of information pertaining to the IT system, management controls used for the IT system, operational controls used for the IT system, physical security environment of the IT system, and environmental security implemented for the IT system processing environment. For example, controls for humidity, water, power, pollution, temperature, and chemicals. Also, different information gathering techniques can be used for inputs. Any or combination of these techniques can be used in gathering information relevant to the IT system within its operational boundaries. These are first one is questionnaire. To collect relevant information, risk assessment personnel can develop a questionnaire concerning the management and operational controls planned or used for the IT system. Next one can be on-site interviews. Interviews with IT system support and management personnel can enable risk assessment personnel to collect useful information about the IT system. For example, how the system is operated and managed. Next can be document review, policy documents, and system documentation. Policy documents, for example, legislative documentation directives. And next is use of automated scanning tool. These are proactive technical methods which can be used to collect system information efficiently. And finally, the output from step one is characterization of the IT system, assist a good picture of the IT system environment, and delineation of system boundary. Okay. Step two is threat identification. So first, what is threat? A threat is the potential for a particular threat source to successfully exercise a particular vulnerability. So, the goal of this step is to identify the potential threat sources and compile a threat statement listing potential threat sources that are applicable to the IT system being evaluated. A threat source is defined as any circumstances or events with the potential to cause harm to an IT system. The common threat sources can be natural, human, or environmental. Natural threats can be floods, earthquakes, landslides, electrical storms, and other such events. Human threats are either enabled by or caused by human beings, such as unintentional act or deliberate actions like network-based attacks, malicious software upload, unauthorized access to confidential information. And environmental threats can be long-term power failure, pollution, chemicals, liquid leakage, etc. So the output from step 2 is a threat statement containing a list of threat sources that could exploit its system vulnerabilities. Now comes to step 3. Step 3 is vulnerability identification. The goal of this step is to develop a list of system vulnerabilities, means flaws or weaknesses of the system that could be exploited by the potential threat sources, which we discussed in step 2, threat identification. Got it? Okay. Let's take an example. Threat source can be a terminated employee, and the vulnerability is terminated employee system ID that are not removed from the system. And threat action can be dialing into the company's network and accessing company proprietary data. Uh, uh, we can take another example. Uh, Under threat sources, unauthorized users. For example, hackers, computer criminals, or terrorists. Here, vulnerability is suppose the vendor has identified flaws in the security design of the system. However, new patches have not been applied to the system, and threat action can be obtaining unauthorized access to sensitive system. Okay. Now comes to vulnerability sources. Vulnerability sources can be previous risk assessment documentation of the IT system assessed, or the IT systems audit reports, system anomaly reports, security review reports, and system test and evaluation reports. And it also can be vulnerability risk from vulnerability databases. Next one is security advisories and vendor advisories and system software security analysis. Next is system security testing for vulnerabilities. Proactive methods employing system testing can be used to identify system vulnerabilities efficiently. Test methods include automated vulnerability scanning tool, which we already discussed, security test and evaluation, and penetration testing. And the output from step 3 is a list of the system vulnerabilities that could be exercised by the potential threat sources. Now comes to step 4. Step 4 is control analysis. The goal of this step is to analyze the controls that have been implemented or are planned for implementation by the organization to minimize or eliminate the likelihood or probability of a threat exercising a system vulnerability. Control methods. Security controls encompasses the use of technical and non-technical methods. Technical controls are access control mechanisms, identification and authentication mechanisms, encryption methods, intrusion detection software. Non-technical controls are management and operational controls, such as security policies, operational procedures, and personal, physical, and environmental security. Now comes to control categories. The control categories for both technical and non-technical control methods can be further classified as either preventive or detective. As discussed, development of a security requirement checklist or use of an available checklist will be helpful in analyzing controls in an efficient and systematic manner. So output from step 4 is list of current or planned controls used for the IT system to mitigate the likelihood of a vulnerabilities being exercised and reduce the impact of such adverse event. Step 5 is likelihood determination. To derive an overall likelihood rating that indicates the probability that a potential vulnerability may be exercised, the following governing factors must be considered. threat source, motivation, capability, nature of the vulnerability, and existence and effectiveness of current controls. And here, output is likelihood rating, which can be high, medium, or low. Now, step 6 is impact analysis. This is the measure step in measuring level of risk is to determine the adverse impact resulting from a successful threat exercise of a vulnerability. So before beginning the impact analysis, it is necessary to obtain some necessary information like system mission, system and data criticality, system and data sensitivity. This information can be obtained from existing organizational documentation such as the mission impact analysis report, business impact analysis, or asset criticality assessment report. If this documentation does not exist or such assessments for the organizations IT assets have not been performed, the system and data sensitivity can be determined based on the level of protection required to maintain the system and data's availability, integrity, and confidentiality. Regardless of the method used to determine how sensitive an IT system and its data are, the system and information owners are the ones responsible for determining the impact level for their own system and information. There is a list provides a brief description of each security goals and the consequences or impact of its not being met. First one is loss of integrity. System and data integrity refers to the requirement that information be protected from improper modification. Next is loss of availability. If a mission critical IT system is unavailable to its end users, the organization's missions may be affected. And the next one is loss of confidentiality. System and data confidentiality refers to the protection of information from unauthorized disclosure. Some tangible impacts can be measured quantitatively in lost revenue. The cost of repairing the system or the level of effort required to correct problems caused by a successful threat action. Other impacts, for example, loss of public confidence, loss of credibility, damage to an organization's interest cannot be measured in a specific unit, but can be qualified or described in terms of high, medium, or low impacts. And the output from this step is magnitude of impact, which can be high, medium, or low. Now comes to step 7, which is risk determination. The purpose of this step is to assess the level of the risk to the IT system. The determination of the risk for a particular threat vulnerability pair can be expressed as function of the likelihood of given threat sources attempting to exercise a given vulnerability, the magnitude of the impact should a threat source successfully exercise the vulnerability, and the adequacy of planned or existing security controls for reducing or eliminating risk. So, to measure risk, a risk scale and a risk level matrix must be developed. And here the output is risk level, which can be high, medium, or low. Now, step 8 is control recommendations. During this step of the process, controls that could mitigate or eliminate the identified risk as appropriate to the organization's operations are provided. The goal of the recommended control is to reduce the level of risk to the IT system and its data to an acceptable level. Number of factors should be considered in recommending controls and alternative solutions to minimize or eliminate identified risk. Uh, this can be effectiveness of recommended options, legislation and regulation, organizational policy, operational impact, safety and reliability. The control recommendations are the result of the risk assessment process and provide input to the risk mitigation process, during which the recommended procedural and technical security controls are evaluated, prioritized, and implemented. And output from step 8 is recommendation of controls and alternative solutions to mitigate risk. Now the final step is result documentation. Once the risk assessment has been completed, means threat sources and vulnerabilities identified, risk assessed and recommended controls provided, the result should be documented in an official report or briefing. So the output from step 9 is risk assessment report that describes the threats and vulnerabilities, measures the risk and provide recommendations for control implementation. Okay. Okay. Now comes to risk mitigation. Risk mitigation is the second process of risk management, involves prioritizing, evaluating, and implementing the appropriate risk reducing controls recommended from the risk assessment process. Because the elimination of all risk is usually impractical or close to impossible, it is the responsibility of senior management and functional and business managers to use the least cost approach and implement the most appropriate controls to decrease mission risk to an acceptable level with minimal adverse impact on the organization's resources and mission. Now comes to risk mitigation strategies. So, risk mitigation can be achieved through any of the given risk mitigation options. First one is risk assumption or acceptance. To accept the potential risk and continue operating the IT system or to implement controls to lower the risk to an acceptable level. Next is risk avoidance. To avoid the risk by eliminating the risk cause and consequences. For example, forgo certain functions of the system or shut down the system when risks are identified. Next is risk limitation. To limit the risk by implementing controls that minimize the adverse impact of a threat's exercising a vulnerability. For example, use of supporting preventive detective controls. Now, next is risk planning. To manage risk by developing a risk mitigation plan that prioritizes, implements, and maintains controls. Next is research and acknowledgement. To lower the risk of loss by acknowledging the vulnerability or flaw and researching controls to correct the vulnerability. And the last one is risk transference. To transfer the risk by using other options to compensate for the loss, such as the purchasing insurance. So, it may not be practical to address all identified risks, so priority should be given to the threat and vulnerability pairs that have the potential to cause significant mission impact or harm. Now comes to risk mitigation methodology. The given risk mitigation methodology describes the approach to control implementation. Here, the step first is prioritize actions. It is based on the risk levels presented in the risk assessment report. And here, the output is actions ranking from high to low. Step 2 is evaluate recommended control options. Here, evaluate the controls recommended in the risk assessment process. And here, output is list of feasible controls. Now, step 3 is conduct cost benefit analysis. To aid management in decision making and to identify cost effective controls, a cost benefit analysis is conducted. And output of this step is cost benefit analysis describing the cost and benefits of implementing or not implementing the controls. Now, next step is step 4, select controls. On the basis of the results of the cost benefit analysis, management determines the most cost effective controls. So here the output is select controls. And step 5 is assign responsibility. Appropriate persons who have the appropriate expertise and skill sets to implement the selected controls are identified and responsibility is assigned. So here the output is list of responsible persons. Now, next step is develop a safeguard implementation plan. During this step, a safeguard implementation plan or action plan is developed. The plan should at a minimum contain some information like risk and associated risk levels. Associated risk levels means output from risk assessment reports. And recommended controls, prioritized actions, selected plant controls, required resources for implementing the selected plant controls, list of responsible teams and staff, start date for implementation, target completion date for implementation, maintenance requirements. So here output is safeguard implementation plan. Okay. Now comes to final step. Step 7, implement selected controls. Depending on individual situations, the implemented controls may lower the risk level but not eliminate the risk. And this is called the residual risk, which is output of this step. Okay. Now comes to controls. In implementing recommended controls to mitigate risk, an organization should consider technical management and operational security controls or a combination of such controls to maximize the effectiveness of controls for their IT systems and organization. Security controls, when used appropriately, can prevent, limit, or deter threat sources damage to an organization's mission. So there are three types of controls: technical security controls, management security controls, and operational security controls, which we will discuss in next slide. First one is technical security controls. Technical security controls for risk mitigation can be configured to protect against given type of threats. Technical controls can be grouped into the given major categories according to primary purpose. First one is supporting controls. Supporting controls are generic and underlie most IT security capabilities. These controls must be in place in order to implement other controls. Next is preventive controls. Preventive controls focus on preventing security breaches from occurring in the first place. And next is detect and recover. These controls focus on detecting and recovering from a security breach. Okay. Next comes to management security controls. Management security controls, in conjunction with technical and operational controls, are implemented to manage and reduce the risk of loss and to protect an organization's mission. Management security controls further divided into preventive, detection, and recovery controls. First one is preventive management security controls. Uh, these controls assign security responsibility, develop and maintain system security plans, implement personal security controls, including separation of duties, least privilege, and user computer access registration and termination, and conduct security awareness and technical training. Next one is detection management security controls. These controls implement personal security controls, including personal clearance, background investigations, rotation of duties. also conducts periodic review of security controls, perform periodic system audits, conduct ongoing risk management to assess and mitigate the risk, authorize IT system to address and accept residual risk. And next one is recovery management security controls. It provides continuity of support, establish an incident response capability. Next comes to operational security controls. Operational controls implemented in accordance with the base set of requirements, for example, technical controls and good industry practices, are used to correct operational deficiencies that could be exercised by potential threat sources. So, what comes under these controls? Preventive operational controls. These controls limit external data distribution, control data media access and disposal, control software viruses, safeguard computing facility, securing wiring closets, provide backup capability, establish off-site storage, protect laptops, personal computers, and workstations, protect IT assets from fire damage, provide emergency power source. And next is detection management security controls. It provides physical security, for example, use of motion detectors, closed circuit television monitoring, sensors, and alarms, and ensures environmental security, for example, use of smoke and fire detectors, sensors, and alarms. Okay, next comes to cost benefit analysis. To allocate resources and implement cost effective controls, organizations, after identifying all possible controls and evaluating their feasibility and effectiveness, should conduct a cost benefit analysis for each proposed control to determine which controls are required and appropriate for their circumstances. Its purpose is to demonstrate that the cost of implementing the controls can be justified by the reduction in the level of risk. For example, the organization may not want to spend $1,000 on a control to reduce a risk of $200. So, a cost benefit analysis for proposed new controls or enhanced controls encompasses the determining the impact of implementing the new or enhanced controls, determining the impact of not implementing the new or enhanced controls, estimating the cost of the implementation, and assessing the implementation cost and benefits against system and data criticality. Now comes to residual risk. The risk remaining after the implementation of new or enhanced control is the residual risk, because practically no IT system is risk free and not all implemented controls can eliminate the risk they are intended to address or reduce the risk level to zero. And the final step is evaluation and assessment. In most organizations, the network itself will continually be expanded and updated, its component change and software application replaced or updated with newer versions. These changes mean that new risk will surface and risk previously mitigated may again become a concern. Thus, the risk management process is ongoing and evolving. So, guys, finally, a successful risk management program will rely on senior management's commitment, the full support and participation of the IT team, the competence of the risk assessment team, the awareness and cooperation of members of the user community, and ongoing evaluation and assessment of the IT related mission risk. Hope you enjoyed the session. Thank you.